In this video, I'll be going through how to set up Bayesian data analysis software to use in R. Previously, you should have installed or updated the R, RStudio, and RTools components and configured your personal package library, set up Git and GitHub, which is optional at this stage, but might as well do it. And you should be familiar with the basics of our studio, basically, the layout. And so if any of these things is not if you've not checked any of these boxes, I recommend you go back to one of the previous videos that talks about those things. So in this video now, we will be installing the packages and accessory software from our studio environment. So there's four things that are really necessary. So tidyverse is not directly connected to Bayesian data analysis, but it's a bundle of packages with lots of useful data science tools that are very widely used in many examples, including ggplot2 for making visuals, dplyr and purrr for manipulating data, etc. The package remotes allows you to install packages from other places that aren't controlled by CRAN, so GitHub primarily. And the package brms is tools for Bayesian data analysis and has a lot of dependencies that are installed alongside, including Rstan. And then CmdstanR is also a package for Bayesian software analysis. It is also used by brms, but has to be installed separately. All right, so before just showing you the installation steps, I just want to go over what these tools are and how they work together. So Stan is the um, primary tool for Bayesian data analysis that we will be using in this course. It's not the only one out there, but I think it's becoming one of the more widely used options out there. It is a software and programming language developed specifically for Bayesian data analysis. Similar to R, it is free and open source and has a big community of developers and contributors. And it's very flexible, so it can be used in many different programming environments, including R, which is what we will be doing. So I wanted to briefly show a very simple example of a Stan model. So this is the model in a mathematical notation. So this is your basic linear regression model where you have a response variable and a predictor variable, and those are related by an intercept and a slope. And then there's some kind of error term. So we call this just a Gaussian linear regression. And so in Stan, the typical anatomy of a Stan model will have a chunk that defines the data. So, how many points you have, and then your X and your Y. And then you have a chunk that defines your parameters, in this case, alpha, beta, sigma. So you see those here. And then a chunk that defines your model. So in this case, it's just the basic likelihood model of it's the syntax is recognizably similar to the mathematical syntax. You can just it's basically the same as this, just written in characters that a computer can work with. So, and this syntax is actually in a language called C++, which, you know, it's just useful to know that as a background. You won't have to learn how to code your own Stan models or use C++, but I like to see the Stan code um, as an example, and because it makes it a lot easier to relate the theory to what the computer is doing. And so having some familiarity with the pieces of a Stan model can be helpful. All right, so in order to use Stan in R, we need some kind of interpreter. And so there are two that you'll be installing. Um, the first is called Rstan, and this is an R package. And this is something that runs Stan code inside of R. and it uses a C++ interpreter. So this is why you had to install R tools in the previous module. So the way Rstan typically works is you might write your model in the stan syntax and save it to some kind of external file with a .stan suffix. This is basically just a text file. And then inside of R, you will point to that um, file as your model and then point to the data, either read into your environment or as a file. And so this is just a way of running stan inside R, but it still uh, codes everything in this stan language. It's just converting it to R. And then CmdstanR is an alternative. It's also an R package, and similar to Rstan, it requires R tools. But what's different about it is that it uses, instead of doing everything inside of R, it uses an external software called CmdStan to compile the models and run simulations, what have you. So it's used very similarly as Rstan. You'll still like write a model as a text file and then read it into R and run it through the R console. Um, it's the syntax is a little different, but essentially from the user experience, it's basically the same thing as Rstan, but what's happening under the hood is different. So just to go over the differences between these things, why we're even talking about them both. Rstan is older and it's used a lot in a lot of help documents and examples. So I figured it's worthwhile to just be familiar with what it is and to have it, and it's automatically installed when we install some of these other packages you'll be using. And the Rstan is also managed by CRAN, the R organization, so it's a little bit easier to install. Whereas CmdstanR is a newer system that's becoming more widely used. So we're seeing more and more examples. Um, for your purposes, it's actually using them isn't that different. It's just a matter of installing them. And it's developed outside of CRAN, so it's actually distributed through GitHub. So it's a little bit more difficult to install, but it's also because it's less strictly regulated, it's better to keep up with the speed of new Stan releases. Whereas with the Rstan package, it's got to go through a few more steps to be able to keep up. So the main benefit of CmdstanR is that there's less memory overhead, it's less prone to crashing, so I recommend using this, but it's a very, very small part of what you'll actually be learning. brms is the main tool that you'll be using through R. It is an R package for a whole Bayesian data analysis workflow, and it's really designed as a wrapper on top of other tools to make specifying complex models easier. So you'll be learning about multi-level models, different kinds of error distributions. It just has, it's a more user-friendly interface for dealing with the kinds of complicated models that come up in ecology. And it translates syntax that's fairly familiar to our users into Stan code. So you don't have to write the Stan code. The brms code is a little bit easier to learn. What I don't like about it is that it's harder to relate the code to the theory, but it also writes Stan code for you. So once you write your brms model, you can open up your Stan model and get a better sense of what the computer is actually doing, theoretically. And brms, it's another layer on top of the other tools. So it works with, it's doing the steps that you would be doing with Rstan or CmdstanR, but it's another layer on top of that. And it also has a lot of useful integrations with other Bayesian packages that operate in different parts of the workflow, such as, summarizing, comparing models, making summary statistics. So it's very useful and there's a lot of help documentation available. All right, so stepping back, seeing how all these things fit together. So here is you, tiny you on your giant computer. You're still driving the same car, so to speak. You're still using RStudio, but now you have a few more components under the hood. Um, you're inside of the R environment, which I'm representing in this circle. Um, you have the brms package, and that's using either CmdstanR or Rstan to run Bayesian models. If you're using CmdstanR, it's speaking to this other software outside of R. And then you still have your whole version control system with the Git software speaking to GitHub and then RStudio's interacting with those. So a lot of pieces, but they fit together nicely, and it's from a user experience, it's still really one tool. All right, so now I'm going to exit here and go back to my Windows sandbox where I've installed R and RStudio and all the other things. So I'm just going to demonstrate the package installation. This is pretty easy because we can do it entirely from within RStudio. I'm using the console here. So um, I went over the layout in another video, but this is if you only need to do something once, you can enter it in the console. So there's a couple ways of installing packages. You could just type it into the console, install dot packages, and then the name of the package in quotation marks. So this is first going to install tidyverse. And there's a lot of packages in tidyverse, so sometimes you get this pop-up. Do you want to install? Well, I'm just going to say yes. And that is going to take a while, but you'll notice now in my Windows library, I've got a bunch of stuff under there. It's easier to see your packages through this package tab. So you have your system library. Um, Oops, that's not what I meant to do. It might take a while for my user library to show up there. Okay, still going. So it's having an issue with this last package, XML2, which is fine. I don't think I need it for anything right now. But everything else has been installed. And now we have this separate user library and system library. And there's a lot of packages. All right, so the next, I'm just going to clear the console because it's getting messy. You can press this little broom. Um, Now I'm going to install a package called remotes. Okay, it's just one, so that's relatively easy. And so next package is actually CmdStan, which requires remotes to install. So there's a couple ways of doing this. So you have to load the remotes package in some way. So a standard way of doing that is just going like library remotes, and then all the packages, all the functions right, within remotes will be available. You can also um, do this like remotes with two colons, and that's just referencing remotes and then all the functions within it. So if you've loaded it, if you've run this library remotes thing, you don't have to do this step, but I find it can sometimes be helpful for seeing where a function comes from. So I'm going to use this function called install GitHub. And for CmdstanR, I have the code for this in the written instructions. But this is installing from a GitHub repository. So it recognizes the first part of the URL that's like https://github.com. And then here's the GitHub username of the developers, and then the name of the package or the repository, CmdstanR, and just press enter. And that's just going to take a second. There we go. So it's just downloading the repository, installing 7. So this has a few uh, other packages that what do they call those? Dependencies. Yeah. So it's installing dependencies. And so it takes a little longer when there's more packages to install. Move this over. Da, da, da. Okay, now I have more packages here. Um, so while I'm in CmdStan brain, I'm going to install the CmdStan software, which you can do through their website, downloading, what have you, but I find it a little easier just to do it straight through R. Um, I'm just going to clear this out to make space. So all you have to do is, well, I'm going to demonstrate it without loading the package. So Command Stan R and then install Command Stan. All right. So if I click enter, it's just installing the software on my computer. Um, C++ toolchain is required, so I've already installed that through RTools. Okay, I don't know what that means, but I don't think it's a problem. Don't think that's a problem either. Takes a little bit. Don't know what's going on there. I'm not going to worry about it. Okay. All right, it's taking a little time. Okay, more computer ease. I can hear my computer working. Could pause the recording, but it's already gone on for so long. Well, might fast forward a little bit. At least you know if it takes this long on your computer, it's normal. Hope this isn't stuck in some kind of loop. Hmm. Just gonna pause the recording. Okay, that took a while, so but I waited patiently, and thankfully, CmdStan has finished installing. There is, let's see, so um, CmdStan path set to blah, 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 blah. So hopefully, now R knows where to look for CmdStan. Whew, so many things. Um, all right, so a couple more things to install. I'm just gonna clear my console. This doesn't get rid of what's run before, it just shifts it up. Um, let's see, to find my, oh, there we go. Okay, so the next thing I'm going to install is brms, which installs a lot of things with it. Installed up packages, brms, dependencies. You can see there's a lot of things here. That's just going to take a little bit. Bridge sampling, another good package. Right. All right, so not quite as time consuming as tidyverse. Um, so the last thing I just want to mention is this optional package called Rethinking, which is used in some of the help examples I'm going to recommend. So it also uses the remotes package. So just install underscore GitHub, and then the user is RMCEL McElreath. Oh, sorry, Reef. I have this in the written instructions, and the repository is called Rethinking. Um, Fingers crossed this works. Just has one dependency. Okay. I should mention the RTools software, I believe, is also used when you're installing packages from GitHub, depending on how they're set up. All right, now it's done. And that's it. We should be good to go with our Bayesian data analysis. Fingers crossed we don't have too many technical problems at the workshop. All right.